Hey guys, it's Danny here from Disrupt Tutoring, and as always it is a pleasure to join you. In this video we're going to do a question from the November 2019 Grade 12 Physical Sciences Paper 2. This question deals with writing a balanced chemical equation for the reaction between sulfur powder and an aqueous sodium hydroxide solution. We're told that a spontaneous reaction occurs between these two reactants, and the products are a sodium sulfite solution, a precipitate of sodium sulfide, and water. We need to write the balanced equation along with the state symbols. So to answer this question, you will need to recall the chemical formulae for some of the common radicals containing sulfur, as well as the oxidation numbers of some of the elements occurring in this reaction. So firstly, we know that one of the products contains sulfite, which is SO3 2-. And then we know that another of the products contains sulfide, which is S2-. Then we also have sodium reacting in this reaction. So we need to remember the oxidation number of sodium, and that is 1+. Okay, so now we can write our balanced chemical equation. I'm just going to write the equation first, and then we'll balance it afterwards. So firstly, we start off with sulfur powder, which is a solid, and that reacts with sodium hydroxide in an aqueous solution. And then the products that are formed are a sodium sulfite solution. So we have sodium, and that bonds with the sulfite ion. And since the sulfite ion has an oxidation number of 2-, we will need 2 sodium atoms to bond with the sulfite ion. And that will be an aqueous solution. Then we have our sodium sulfide precipitate, and a precipitate is a solid within an aqueous solution. So we have our sodium sulfide, and once again we have an oxidation number of 2-, so we will need 2 sodium atoms bonding with the sulfide ion, and that will be a solid. Lastly, we have water, which is produced, and that is H2O, and that is a liquid. Okay, so now that we have our equation with the state symbols, we can start to balance it, and I'm just going to use a different color here so that we can see the changes made. So to balance the equation, we can start by comparing the number of atoms of each of the elements on either side. We can then try to make them match by changing one at a time. So let's first write down the number of each of the atoms on the left and on the right hand side of the equation. On the left hand side we have 1 atom of sulfur, and on the right hand side we have 2 atoms of sulfur. Then on the left hand side we have 1 atom of sodium, and on the right hand side we have 4 atoms. On the left hand side we have 1 atom of oxygen, and on the right hand side we have 4. And then finally hydrogen. On the left hand side we have 1, and on the right hand side we have 2. So now we can start balancing the equation by trying to make these numbers match. So we can start with the the sulfur, and we can multiply this by 2, and then we have our sodium, our sulfur atoms matching on either side, and then we need to balance the sodium on either side. So if we look at the sodium, we have 1 on the side and 4 on the side. So if we try putting a 4 in front of the sodium, then we have our sodium atoms balanced. But now we've also included 4 oxygen atoms over here and 4 hydrogen atoms. So that balances the oxygen as well, but it doesn't balance the hydrogens because we only have 2 hydrogen on the right hand side, where we now have 4 on the left hand side. So let's try and make some changes on the right hand side over here. So to increase the number of hydrogen on the right hand side, we can multiply this by 2, and then we have 4 atoms of hydrogen on the right hand side and 4 atoms on the left hand side. But once again, now we've got an increased the number of oxygen atoms on the right-hand side by multiplying water by 2. So that means that there are now 5 atoms of oxygen on the right-hand side and only 4 on the left-hand side. So this is an indication that we need to try a different number. So let's, instead of saying 2, let's just say 3. So if we multiply H2O by 3, that means we now have 6 hydrogen atoms on this side and also 6 oxygen atoms on this side, on the right-hand side of the equation. So then if we look at the left-hand side of the equation, we can get 6 hydrogen and 6 oxygen atoms on the left-hand side by multiplying NaOH by 6. And that gives us 6 atoms of sodium on the left-hand side, where we only have 4 on the right-hand side. So here we don't want to change the coefficient of this term because we have already sorted out the oxygen. So we've already balanced the oxygen on either side with the 3 here and the 6 here. So now what we need to do is we need to look at this term and see how we can balance the sodium on the left-hand side and the right-hand side. So we have 6 on the left-hand side, and we have 2 in the first term, and we only have 2 in the next term, so we can multiply this term by 2. And then we have 2 sulfur in this term, and then also 1 sulfur in this term, which we can balance on the left-hand side of the equation by putting a 3 in front of the sulfur. So for each of our reactants, so we have a mole ratio of 3 to 6 for the reactants, and then for the products, we have a mole ratio of 1 to 2 to 3. Okay, so if that was a little bit difficult to follow on with, just rest assured that it will become easier the more practice you get and the more types of these problems you go through as you learn the little tricks. So this will be the mole ratio of our final balanced equation. And yeah, okay. So before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible. Read all about them in the description below. Be sure to visit our website for more of these epic tutorial videos. If you can't find the answer to your question, you can send us the question and we'll respond with a personalized video just for you. Until next time, stay epic.